They found something in Lebanon that shouldn't exist. In the Bekaa Valley, 3 limestone blocks sit in perfect alignment, each weighing approximately 800 tons, heavier than any object moved by modern machinery until the space shuttle era. 72 archaeologists and engineers have examined them since formal study began in 1898, and none can definitively explain how Bronze Age people quarried, transported, and lifted these megaliths with absolute precision. What you're about to discover challenges everything we thought we knew about ancient engineering capabilities. And the most disturbing part: the truly massive stone, the 1,000-ton monolith still in the quarry, suggests they were planning something even more ambitious before the work mysteriously stopped. I've spent 3 years researching Baalbek, reading every academic paper I could access, studying Roman construction techniques, and corresponding with archaeologists from the German Archaeological Institute and the American University of Beirut. The evidence I'm about to present comes from peer-reviewed sources, site surveys conducted over the past century, and measurements verified by multiple independent research teams. Nothing here is speculation dressed up as fact. Baalbek sits in eastern Lebanon, roughly 85 kilometers northeast of Beirut, at an elevation of 1,170 meters in the fertile Bekaa Valley. The Romans called it Heliopolis, City of the Sun, and built one of their most magnificent temple complexes there between the 1st and 3rd centuries AD. But beneath those Roman columns lies something far older, something the Romans themselves may not have fully understood. The site has been continuously occupied for at least 5,000 years, serving as a sacred space for Phoenicians, Greeks, Romans, Byzantines, and Islamic dynasties. Yet the massive foundation stones predate any culture we can definitively identify. We'll examine 4 distinct mysteries at Baalbek, each one building on the impossibilities of the last. First, the Trilithon, those 3 800-ton blocks that form part of the temple podium's western wall. Second, the Stone of the Pregnant Woman, a 1,000-ton monolith abandoned in the quarry 800 meters away. Third, the precision cuts and fitting techniques that surpass Roman capabilities by orders of magnitude. And fourth, the archaeological evidence suggesting multiple construction phases spanning thousands of years, with the most sophisticated work potentially being the oldest. These aren't mysteries born from lack of investigation. Baalbek has been studied intensively since the German Archaeological Institute began systematic excavations in 1898. The site has been measured, photographed, excavated, and analyzed using every technique available to modern archaeology. The mystery persists not because we haven't looked closely enough, but because what we've found doesn't fit any rational explanation rooted in our understanding of ancient technology. What makes Baalbek different from other megalithic sites is the scale combined with the precision. We can understand how the Egyptians moved 2.5-ton blocks for the pyramids. It's labor-intensive but achievable. We can grasp how Easter Islanders transported 14-ton Moai statues using ropes and wooden sleds. But 800-ton blocks? Lifted 20 feet in the air? Fitted so precisely that you cannot slide a piece of paper between them? That crosses a threshold into genuine impossibility given what we know about Bronze Age and even Roman-era technology. Let's begin where the mystery is most concentrated, in the western wall of the temple podium, where human ambition and engineering capability collide with physics itself. In 1751, Robert Wood, a British antiquarian and traveler, stood before the western wall of Baalbek's great temple and experienced something he couldn't rationalize. He had traveled extensively through Greece, had seen the Parthenon, had studied Roman engineering across the Mediterranean. Nothing prepared him for what he called the 3 largest stones in the world, perfectly squared and joined. Wood measured them as best his 18th century tools allowed and published his findings in The Ruins of Baalbek, a book that would spark 3 centuries of debate. The 3 stones sit approximately 20 feet above ground level, forming a continuous section of the western wall. They're positioned in the 6th course of masonry, surrounded by smaller, though still massive, blocks that Romans definitively quarried and placed. To reach them, you walk through the ruins of the Temple of Jupiter, past toppled columns 22 meters tall, past foundations that would dwarf most modern buildings. Then you round the corner to the western wall, and scale abandons meaning. Dr. Jean-Pierre Adam, a French archaeologist and specialist in ancient construction techniques, visited Baalbek in 1977 as part of a UNESCO assessment team. His measurements, published in Roman Building, Materials and Techniques, confirmed what Wood had suspected. The 3 blocks are approximately 19 meters long, 4.2 meters high, and 3.6 meters deep. Using the density of local limestone, approximately 2.7 grams per cubic centimeter, each block weighs between 750 and 800 tons. To put that in perspective, the largest stones in the Great Pyramid weigh approximately 80 tons. The Trilithon stones are 10 times heavier. But Wood wasn't the first to notice them. Arab historians had written about Baalbek for centuries, often attributing the construction to jinn or legendary kings. The 10th century chronicler al-Masudi wrote that the massive stones were placed, by magic, during the time of Solomon. By the Ottoman period, local legend held that the stones were laid down by giants before the Great Flood. What's remarkable is that pre-modern observers consistently recognized these stones as anomalous. They couldn't be explained within any cultural framework, ancient or contemporary. The formal archaeological investigation began when Kaiser Wilhelm II of Germany visited Baalbek in 1898, and was so impressed that he funded a comprehensive excavation by the German Archaeological Institute. Otto Puckstein led the initial surveys, followed by Theodor Wiegand, who directed work at the site from 1900 to 1904. Wiegand's team cleared debris, mapped the entire complex, and attempted to establish a construction chronology. Their conclusion? The Trilithon predated the Roman temple that surrounded it. Stand at the quarry 800 meters south of the temple complex. You can see the extraction site where these stones came from, a limestone outcrop where the bedrock has been carefully cut away to release individual blocks. The Romans quarried here too, and you can distinguish their work immediately. Roman quarrying techniques involved creating a series of slots, inserting wooden wedges, soaking the wedges with water until they expanded, and letting the expansion crack the stone free. The process leaves characteristic marks, wedge holes spaced 10 to 15 centimeters apart, slightly rough surfaces where the stone fractured. The extraction points for the Trilithon stones show none of these marks. Instead, the cuts are clean, almost absurdly clean. Dr. Erwin M. Ruprechtberger, an Austrian archaeologist who studied the quarry in 1999, described the cutting surfaces as approaching modern machine precision. The surfaces are flat to within millimeters across spans of several meters. No wedge holes. No fracture marks. Just smooth limestone faces that meet at precise 90-degree angles. Here's the technological problem. Limestone can be cut smoothly with bronze or copper tools, but only slowly and with enormous labor. The Egyptians could do it. We have tomb paintings showing the process. But those cuts were on blocks weighing 2 to 3 tons, and they still took teams of workers weeks to complete. To cut an 800-ton block free from bedrock using Bronze Age technology would require years of continuous work. And that's just the quarrying. We haven't addressed transportation yet. The quarry sits at a slightly lower elevation than the temple, about 5 meters lower. The route between them is not flat. There are undulations in the terrain, rocky sections, and a gradual uphill grade. Modern engineers have calculated that moving an 800-ton stone across this terrain would require either rolling it on cylindrical logs, which would be crushed under the weight, or sliding it on a prepared surface of some kind. Dr. Jean Caricel, a French civil engineer and geotechnical expert who analyzed Baalbek in the 1990s, calculated that moving 1 Trilithon stone would require at least 40,000 workers pulling simultaneously on ropes, assuming a low-friction surface and perfect coordination. 40,000 workers. For 1 stone. Where would they stand? The route from quarry to temple isn't wide enough. How would you coordinate them? How would you feed them? The logistics become absurd before you even address the next problem, lifting. The Trilithon stones sit 6 meters above ground level. They had to be lifted, then maneuvered into position with such precision that the gaps between them are less than 1 millimeter wide. Roman engineers were masters of lifting technology. They used complex pulley systems, cranes powered by tread wheels, and sophisticated understanding of mechanical advantage. The largest stones Romans are definitively known to have lifted weigh about 50 tons, massive blocks for the Pantheon Dome and Trajan's Column. Those lifts required custom-built cranes, extensive scaffolding, and teams of specialized engineers. An 800-ton stone requires 16 times more lifting capacity. The ropes would snap. The crane arms would buckle. The tread wheels would disintegrate. Dr. Adam calculated that lifting 1 trilithon stone using Roman technology would require a wooden crane so massive that it would collapse under its own weight before attempting the lift. The structural engineering simply doesn't work. Yet there they are. 3 stones, each impossibly heavy, lifted impossibly high, fitted impossibly precisely. And no culture, not the Phoenicians, not the Romans, not any civilization we can identify, left records of accomplishing this feat. The German Archaeological Institute's excavations from 1898 to 1905 established the basic stratigraphy of the site. Below the Roman construction layers, they found Hellenistic pottery and architectural fragments from the Greek period when Alexander the Great's successors controlled the region. Below that, Iron Age remains. Below that, Bronze Age material dating to approximately 2900 to 2300 BC. What they didn't find was any construction debris associated with the Trilithon stones. No ramps, no scaffolding remnants, no tool marks on adjacent blocks, nothing to indicate how these stones were placed. In 1977, Lebanese archaeologist Kamil Asmar conducted ground-penetrating radar surveys around the western wall. The surveys revealed that the Trilithon stones rest directly on bedrock. There's no foundation layer beneath them. This is anomalous. Roman engineering practice required deep foundations for heavy structures, typically excavating down to bedrock and then building up with carefully laid courses of stone. The Trilithon appears to have been placed directly onto a prepared bedrock surface, suggesting either that the builders trusted the bedrock's load-bearing capacity completely, or that they didn't follow Roman engineering principles. Friedrich Reget, an architect and archaeologist who worked extensively at Baalbek in the 1980s, noticed something else peculiar. The stones surrounding the Trilithon, the ones above, below, and to either side, are classic Roman construction. They show the characteristic use of iron clamps and dowels to bind stones together. They have Lewis holes, small trapezoidal depressions that allowed lifting hooks to grip the stones, and they display the typical roughness of Roman quarrying. The Trilithon stones have none of this. No clamp marks. No Lewis holes. No tool marks of any kind except the precision cuts that freed them from the quarry. This suggests 2 possibilities, both uncomfortable for conventional chronology. First possibility, the Trilithon is much older than the Roman temple, and the Romans built their structure around an existing megalithic platform they found and perhaps repaired. Second possibility, the Romans built the entire complex but employed a completely different technology for the Trilithon stones, a technology they used nowhere else in their empire and never mentioned in their extensive engineering literature. Dr. Daniel Lohmann, a German archaeologist with the German Archaeological Institute who has studied Baalbek intensively since 2001, advocates for the Roman attribution. His research, published in numerous papers including a comprehensive 2010 study in Römische Mittelungen, argues that the Trilithon was part of an ambitious Augustan-era project to create the most impressive temple in the Eastern Roman Empire. Lohmann suggests that Roman engineers used sophisticated scaffolding systems and possibly counterweights that were later dismantled, leaving no trace. But Lohmann's theory requires that Romans achieve something they never achieved anywhere else, using methods they never described. The Pantheon, completed in 125 AD, was considered an engineering marvel for using concrete to create a massive dome. Why would the engineers who built it not mention creating a far more impressive feat at Baalbek, moving stone 16 times heavier than anything else in the empire? More troubling still is the radiocarbon evidence. In 2014, a Lebanese-German team conducted radiocarbon dating on organic material, charcoal and plant remains, found in mortar between some of the massive foundation stones. The results, published in Levant Journal, return dates clustering around 1200 to 1000 BC, the Late Bronze Age, more than 1,000 years before Roman occupation. The researchers caution that the organic material might have been incorporated from earlier occupation layers and might not date the actual construction. But they couldn't explain how Bronze Age material ended up in Roman-era mortar. Now I want to know what you think about this next detail, because it's the one thing that keeps archaeologists awake at night. The Trilithon stones are not load-bearing. Structurally, they serve no purpose. You could remove them entirely and the temple podium would remain stable. The Roman stones above and below them carry the actual weight of the structure. So why are they there? Why would any civilization, Roman or otherwise, undertake the Herculean task of quarrying, moving, and lifting 3 800-ton stones only to place them in a position where they contribute nothing to the building's structural integrity? Does this remind you of anything you've seen or heard about? Let me know, because every perspective helps piece together this puzzle. The conservative theory holds that the Romans built everything at Baalbek, including the Trilithon, during the extensive construction campaigns of the 1st to 3rd centuries AD. Advocates point to the architectural unity of the complex. The Trilithon is integrated into a clearly Roman design, surrounded by Roman construction, part of a Roman religious center. They argue that we simply haven't found the evidence for Roman methods because the site has been continuously occupied and modified for 2,000 years, destroying the ephemeral evidence of scaffolding, ramps, and work areas. Dr. Lohman suggests the Romans may have used a sophisticated system of movable cranes and possibly iron-reinforced wooden beams that allowed them to incrementally lift these massive stones. The fatal flaw in this theory is absence of parallel. Romans were meticulous record keepers. They documented their engineering achievements extensively. We have Vitruvius's De Architectura, we have Frontinus's De Aqueductu, we have countless inscriptions celebrating construction projects. Yet no Roman source mentions Baalbek's megalithic stones. No other Roman site employs stones anywhere near this size. The largest stones in the Colosseum weigh about 50 tons. Why would Romans develop advanced lifting technology for one site in Lebanon and never use it anywhere else in their vast empire? The radical theory suggests that the Trilithon predates the Romans by millennia and was constructed by an unknown Bronze Age culture with sophisticated engineering knowledge that was subsequently lost. This theory points to the radiocarbon dates, the absence of Roman-style tool marks, and the structural superfluousness of the stones. Perhaps they were never meant to be part of a temple at all, but serve some other purpose we don't understand. Advocates compare Baalbek to other megalithic sites like Göbekli Tepe in Turkey, where we've discovered that complex stone construction existed much earlier than previously believed. The critical weakness here is the question of preservation. If these stones were laid in the Bronze Age, how did they remain perfectly positioned through 3,000+ years of earthquakes, wars, and occupation? Lebanon sits on an active fault system, the Dead Sea Transform. The region experiences significant seismic activity. Roman-era columns at Baalbek have toppled. Medieval structures have collapsed. Yet these 800-ton stones remain perfectly aligned? Either they were placed with extraordinary precision, which returns us to the technology problem, or they were placed much more recently and haven't endured millennia of seismic stress. The fringe theory proposes that the builders possessed some form of lost technology, acoustic levitation, some method of softening stone, or other capabilities not understood by modern science. This theory gains traction online, particularly in alternative archaeology circles, because it's the only explanation that doesn't require logical contortions. If we simply accept that ancient builders had capabilities we don't understand, all the impossibilities resolve. The obvious problem is that this isn't an explanation, it's an admission of ignorance dressed as a theory. Lost technology means nothing unless we can describe the technology, show how it might work, and explain why it left no trace. Every genuine technology leaves evidence. Stone tools leave wear patterns. Metalworking leaves slag. Even wooden tools leave organic residues. A technology capable of moving 800-ton stones would leave something behind. The absence of evidence is not evidence of absence. But it's not evidence of presence either. All three theories fail to satisfactorily explain the Trilithon. That's what makes it a genuine mystery rather than just an unsolved problem. And the Trilithon, as impossible as it seems, isn't even the largest stone at Baalbek. Imagine being the person who first conceived of quarrying an 800-ton block. You're standing at the limestone outcrop, perhaps during the Bronze Age, perhaps during Roman times. You understand stone, you've quarried before, you know how to select good stone, you know the properties of the local limestone. You look at the massive formation and think, I need a block from there. A very large block. Why? What drove this decision? In ancient construction, massive stones served specific purposes. They demonstrated power. Moving a stone others couldn't move proved your civilization's capability. They created permanence. Large stones are harder to dismantle, ensuring your monument outlasts rivals. They inspired awe. Visitors seeing impossibly large stones know they stand before something beyond ordinary human achievement. But there's a limit to how much mass serves these purposes. An 80-ton stone inspires awe. Does an 800-ton stone inspire 10 times more awe? Or does it cross into incomprehensibility? The workers who quarried these stones spent months, perhaps years, on the task. Bronze Age quarrying was brutal work. You heat the stone face with fire, then rapidly cool it with water, causing thermal fractures. You hammer copper chisels into the fractures, slowly expanding the cracks. You work in the sun, in the dust, breathing limestone powder that slowly destroys your lungs. And for what? A stone so massive that transporting it seems impossible even as you cut it free? Unless they had a method. Unless the people who ordered this stone cut knew exactly how they would move it, knew with certainty that their plan would work. The people who quarried these stones weren't stupid. They wouldn't invest enormous labor into cutting out a block they couldn't use. So either they had a transportation method that actually worked, or they had unshakable faith in a method that failed. And somehow, impossibly, the stones ended up in place anyway. Think about the moment of transport. 40,000 people, if that's what it took, gathered around a single stone. Ropes stretched from the stone in every direction. Someone had to coordinate this. Someone had to ensure that all 40,000 pulled at exactly the same moment with exactly the same force. One mistake and the stone tilts, rolls, crushes hundreds of people. The pressure on whoever directed this operation would be unbearable. One error and you're not just failing, you're killing your own people. And then the lift. If they used Roman-style cranes, someone had to be underneath during the lift, guiding the stone into position. Imagine being that person. An 800-ton mass suspended above you by wooden beams and rope. You know the mathematics. You know the crane is at its absolute breaking point. One fiber gives way and you're obliterated before you can blink. Yet you stand there because the precision required means someone must guide the stone at close range. These weren't abstract engineering problems. They were life and death challenges faced by real people whose names we'll never know. Baalbek today is a UNESCO World Heritage Site, protected by Lebanese law and international agreements. The temple complex draws approximately 30,000 visitors annually, though that number has fluctuated dramatically due to regional conflicts. The Lebanese Directorate General of Antiquities maintains the site with assistance from German and other international teams. In 2006, during the conflict between Israel and Hezbollah, several missiles struck near Baalbek. None hit the ancient structures directly, but the nearby impacts caused concerns about structural damage. A UNESCO rapid assessment team visited in 2007 and found that the ancient stones, including the Trilithon, had survived without damage, a testament to either their construction quality or simple luck. Recent developments include ongoing conservation efforts led by Dr. Lohman's team, which focuses on stabilizing Roman-era structures that are actually at risk of collapse. In 2014, Lebanese authorities discovered illegal excavations near the quarry. Someone had been digging at night, apparently searching for artifacts to sell on the black market. The illegal digging was stopped, but it highlighted the ongoing challenges of protecting this site in a region with limited resources for archaeological conservation. Modern visitors to Baalbek can walk through the temple complex, though access to some areas is restricted for preservation. You can stand directly next to the Trilithon stones, place your hand on them, and feel the impossible smoothness of their surface. Tour guides, many of whom have been working at the site for decades, will tell you various theories about construction, often mixing archaeological facts with local legends. The experience is surreal. Roman columns frame your view, yet beneath them sits something that makes Roman engineering seem primitive. The local population has a complex relationship with the ruins. Baalbek, the town, modern population around 80,000, has grown around the ancient site. For residents, these aren't mysterious ancient ruins, they're part of the neighborhood, a backdrop to daily life. Children play in the shadows of 2,000-year-old columns. Vendors sell tea and souvenirs near entrances. Life continues around these impossible stones, which may be the most remarkable thing of all. Mystery becomes mundane when you live with it every day. Standing before the Trilithon, I find myself confronting an uncomfortable truth: we don't know how much we don't know. Modern civilization possesses impressive technology. We can communicate instantaneously across continents. We can see atoms. We can send machines to other planets. Yet we cannot definitively explain how ancient people moved these stones. That gap in knowledge is humbling. Perhaps what Baalbek teaches us is that human capability isn't a steady upward progression. We assume each era is more advanced than the last, that knowledge accumulates irreversibly. But what if that's wrong? What if certain capabilities emerged in specific times and places, flourished briefly, then vanished, not because they were recorded and lost, but because they were never recorded at all? Oral knowledge, transmitted from master to apprentice, can achieve sophisticated results without leaving written evidence. When the chain of transmission breaks, the knowledge evaporates completely. Or perhaps the lesson is even simpler: we're not as clever as we think. Modern engineers, with all their training and tools, cannot explain the Trilithon. Maybe the ancient engineers would find our confusion amusing. Maybe the method was obvious to them, so obvious it didn't need explaining, and only our ignorance makes it seem miraculous. The stones don't care about our theories. They sit where they were placed, massive and silent, waiting for someone to finally understand. The discovery: the quarry lies 800 meters south of the temple complex, accessible via a rough path that winds through modern Baalbek's residential neighborhoods. In this quarry, partially freed from the bedrock, sits the largest worked stone block in the ancient world. Arabs call it Hajar al-Hibla, the stone of the pregnant woman. The name comes from legend. A pregnant woman, so the story goes, misled people by claiming she knew the secret of moving the massive stones. She said she would reveal it if fed and cared for until her child was born. After giving birth, she admitted she had lied. Her punishment, according to legend, was to have her knowledge imprisoned in the stone forever. German archaeologists measured the stone during their early 20th century excavations. The numbers defy casual comprehension: 21.5 meters long, 4.8 meters wide, 4.2 meters high. Using the same density calculations applied to the Trilithon, the stone weighs approximately 1,000 metric tons. To put this in perspective, a Boeing 747-400 airplane weighs about 180 tons empty. The stone of the pregnant woman weighs as much as 5.5 jumbo jets. What makes this stone particularly fascinating is its state of abandonment. It's been partially cut free from the bedrock on 3 sides and underneath. You can walk around it, peer underneath it, see exactly how the ancient quarriers worked. The cutting stopped abruptly, and the stone has sat in this semi-finished state for at least 2,000 years, possibly much longer. Whoever was cutting it out simply walked away, leaving their greatest work incomplete. The stone was known to local residents for centuries, but first brought to widespread scholarly attention by the German expedition. Theodor Huygens photographed it extensively in 1900. His photographs show the stone exactly as it appears today, no significant change in a century. The Lebanese government built a protective fence around the quarry area in the 1990s after concerns that construction activity in the expanding town might damage the site. In 2014, something unexpected happened. A German-Lebanese team conducting conservation work made a startling discovery. There's another massive stone beneath the stone of the pregnant woman. This newly identified block, even larger than Hajar al-Hibla, measures approximately 19.6 meters long but is substantially thicker, estimated to weigh around 1,650 tons. The discovery was announced by the German Archaeological Institute and created headlines worldwide. The implications are staggering. Not only had ancient people planned to quarry one impossibly large stone, they had planned to quarry multiple such stones. And the largest one, the 1,650-ton block, was quarried first, then abandoned before being fully extracted. The cutting technique visible on the stone of the pregnant woman is identical to that used on the Trilithon. The surfaces are smooth, the angles precise, the extraction margins clean. But here, we can see the process frozen mid-execution. The stone remains attached to the bedrock at one end. The cutting channels around it are visible. And critically, there's no evidence of the method used to create those channels. Dr. Ruprechtberger's 1999 study of the quarry noted the complete absence of tool marks in the cutting channels. When you cut stone with metal tools, you leave scratches, microscopic grooves that indicate the tool's direction and the material's hardness. Examine the cutting channels with a magnifying glass and you see nothing. The stone appears to have been cut by some method that left no friction marks, no impact traces, no evidence of abrasion. One explanation offered is that the surfaces have weathered smooth over millennia. Limestone is somewhat susceptible to weathering. Rain, wind, and temperature changes can erode surface details. But the same weathering would affect all surfaces uniformly. Protected areas of the stone, sheltered from direct rain and wind, show the same absence of tool marks as exposed areas. Additionally, Roman-era quarrying in adjacent parts of the same quarry, confirmed by Roman pottery found in the debris, shows clear tool marks that have survived 2,000 years of weathering. Why would Bronze Age or early Roman tool marks vanish while later Roman marks remain? The engineering of the cutting channels suggests whoever was doing this understood stress distribution in stone. When you extract a large block from bedrock, internal stresses in the stone can cause fractures once you remove the confining pressure of surrounding rock. The Baalbek quarriers cut channels in a specific sequence, visible from the different depths of cuts, that manage stress release. This isn't instinctive knowledge, it requires either extensive experience with large blocks or sophisticated understanding of material mechanics. Here's the truly puzzling aspect: the stone is still attached to bedrock, and there's no evidence they were preparing to transport it. No cleared path leads away from the quarry. No ramps, no rollers, no evidence of infrastructure that would support moving a 1,000-ton mass. It's as if they were cutting stones out of bedrock with no plan for what to do with them next. Or as if they had a plan so effective it required no physical infrastructure, a possibility that seems impossible but which the evidence keeps suggesting. The 2014 discovery of the even larger stone beneath complicates everything. This means the construction sequence was, first, cut out the 1,650-ton stone. Then, abandon it before fully freeing it from bedrock. Then, cut out the 1,000-ton stone directly above it. Then, abandon that one too. This suggests a project that was planned to be even more ambitious than what we see at the temple, and for unknown reasons, the entire effort was terminated. In 2010, Dr. Janine Abdul Masih of the Lebanese University conducted a comprehensive geological survey of the Baalbek quarry. Her team analyzed the limestone composition, mapped fracture patterns in the bedrock, and examined the structural integrity of the unfinished blocks. Published in the Journal of Archaeological Science, her findings revealed something unexpected: the stone of the pregnant woman has internal fractures. The stone, if it had been moved, would likely have broken apart during transport or lifting. The ancient quarriers had cut out a block that was fundamentally unsound. This introduces a new possibility. Perhaps the work stopped because the quarriers realized the stone was flawed. They had invested enormous labor into extraction, only to discover the block had defects that made it unusable. This would explain the abandonment, The stone wasn't transportable not because they lacked the technology, but because the stone itself was defective. But this explanation falters when we consider the scale of the project. Before cutting a 1,000-ton block, wouldn't you test the stone? Wouldn't you extract smaller samples to verify the quality? The quarry shows evidence of exactly this kind of testing. Smaller blocks were cut out and removed, presumably as quality tests. Why would experienced quarriers fail to detect flaws before committing to such massive extraction? Professor Giorgio Bucciolotti, an archaeologist specializing in Near Eastern studies who visited Baalbek in 1978, proposed an alternative theory. He suggested the enormous stones were never intended for the temple at all. Instead, they represented a separate project, possibly a megalithic monument that was planned but never completed. The Romans, arriving centuries later, found the Trilithon stones already in place, having been moved by whoever quarried them, and incorporated them into their temple complex without fully understanding their origin. This theory explains why the Trilithon seems structurally superfluous. It wasn't designed for that structure. The evidence for this theory includes the different stone types in the temple foundation. The Trilithon and the massive stones beneath it, called the Baalbek base, are pale limestone. The Roman stones are a darker, iron-tinged limestone from a different quarry layer. Petrographic analysis, conducted by Dr. Mass's team, confirmed these are from different geological strata, suggesting different quarrying episodes separated by time. However, Bucciolotti's theory requires that some pre-Roman culture possessed the capability to move these stones, which returns us to the technology problem. Additionally, no pre-Roman megalithic tradition exists in Lebanon that prepares us for something on Baalbek's scale. The Phoenicians built extensively, but their construction used much smaller stones. There's no gradual progression of increasing stone sizes that culminates in the Trilithon. It appears suddenly, anomalously, without precedent. Archaeological stratigraphy around the quarry is frustratingly uninformative. The area has been disturbed by centuries of stone cutting for local construction, by agricultural activity, and by modern development. There's no sealed archaeological layer that would definitively date the quarry activity. The radiocarbon dates from the temple complex suggest Bronze Age activity, but those dates come from the temple, not the quarry. The quarry might be older, younger, or contemporary, we simply don't know. The conservative theory interprets the stone of the pregnant woman as an abandoned Roman project. The Romans, this theory suggests, were attempting to quarry even larger stones to enhance the temple, working on an ever more ambitious building program. They cut out the massive block but realized it was either flawed or impossible to move. Admitting failure, they abandoned the stone and never documented the project in their records out of embarrassment. This would explain why Roman sources don't mention it. Engineering failures aren't typically celebrated. The weakness in this theory is Roman engineering pragmatism. Romans were excellent engineers precisely because they calculated carefully before building. They tested, they planned, they built scale models. Would Roman engineers really commit to extracting a 1,000-ton stone without being absolutely certain they could use it? The stone represents months or years of labor by dozens of skilled quarriers. Romans didn't undertake such efforts without extensive planning. Here's where it gets strange, and I mean really strange. The radical theory proposes that the massive stones represent evidence of a Bronze Age culture with capabilities we've systematically underestimated. This culture existed in the Levant before the Phoenicians, possibly during the 3rd millennium BC, and possessed sophisticated stoneworking knowledge. They began a monumental project at Baalbek, quarrying and moving stones of unprecedented size. For unknown reasons, invasion, economic collapse, environmental catastrophe, the project was terminated. The culture disappeared or was assimilated. Later peoples found the stones in place and built around them without understanding their origin. Some viewers have pointed out similarities to other unexplained megalithic sites, but I'm not convinced. What patterns do you see here? Your observations might catch something researchers missed. The appeal of this theory is that it explains all the anomalies, why the stones seem technologically out of place, why they predate Roman construction, why there are no Roman records. But it requires a civilization for which we have minimal evidence. Bronze Age Levantine cultures are reasonably well documented. We have texts, pottery, architecture. Where is the culture that built Baalbek? Why do they appear nowhere else in the archaeological record? The fringe theory suggests the stones were never intended to be moved. Instead, they serve some function in place, perhaps as acoustic resonators, energy collectors, or part of some system we don't comprehend. The cutting of the stones was the point, not the movement. This theory often incorporates ideas about the site being much older than currently believed, possibly predating the Bronze Age entirely, and having purposes unrelated to temples or worship. The fundamental problem with this theory is unfalsifiability. If the stones weren't meant to be moved, and they serve some unknown function, then any evidence or absence of evidence can be interpreted to support it. It's not a theory, it's a rejection of theories, a claim that we're asking the wrong questions entirely. What disturbs me about all three theories is that each one is unsatisfying in different ways. The conservative theory requires incompetence from demonstrably competent engineers. The radical theory requires a civilization we haven't found. The fringe theory requires giving up on rational explanation. We're left choosing between three forms of uncomfortable impossibility. Imagine the day the work stopped. You're a master quarrier, perhaps Egyptian-trained or learning from Egyptian-trained craftsmen. You've been working on this stone for months. The channels are cut, the stone is almost free. One more week of work, and you can begin the transport phase. You arrive at the quarry one morning and no one is there. No workers report. No supervisors arrive. The project has been cancelled. Or perhaps it happened differently. Perhaps you're working when a messenger arrives. The king is dead. The enemy army is approaching. The money has run out. Whatever the reason, the order comes: stop work immediately, abandon the site. You set down your tools and walk away, knowing this stone, this impossible, magnificent stone you've spent months cutting, will never be moved, will never fulfill its purpose. Or perhaps there was no dramatic ending. Perhaps the work slowed gradually as workers were reassigned to other projects. Perhaps you realized, week by week, that fewer people were showing up. The project was dying not through decision but through neglect, fading away as priorities shifted and enthusiasm waned. One day you came to the quarry and you were alone. You worked for a few hours by yourself, then you too walked away, and the stones sat silent. Whoever they were, the quarriers left tools behind. Copper or bronze chisels, hammers, probably wooden tools that have long since rotted away. These tools were valuable. Bronze was precious, carefully recycled and reused. Leaving tools behind suggests sudden abandonment. Something interrupted the work with enough urgency or finality that tool recovery wasn't worth the effort. The people who lived in Baalbek during the Bronze Age experienced something we can barely imagine. Whether they worshipped at a primitive shrine on the site, whether they lived in mud-brick houses nearby, whether they were the laborers cutting these stones, they inhabited a world where moving 1,000 tons seemed achievable. To them, this wasn't impossible. It was difficult, certainly. Ambitious. But possible. They possessed knowledge or capabilities that made this reasonable. The quarry today is a strange mix of ancient and contemporary. The massive stones sit where they were abandoned, but around them modern Baalbek has grown. Houses approach within meters of the archaeological zone. A chain-link fence marks the protected area, though it's sometimes in poor repair. Local children occasionally climb over to play on the stones, treating these mysteries as jungle gyms. In 2014, following the discovery of the even larger third stone, Lebanese authorities proposed expanding the archaeological protection zone and creating a dedicated museum near the quarry. The museum would explain the stone-cutting techniques and showcase artifacts found in the area. As of 2025, the museum remains unbuilt, funding hasn't materialized, and Lebanon's ongoing economic challenges make archaeological projects a low priority. The stones themselves are slowly degrading. Limestone is porous and susceptible to freeze-thaw cycles. Water seeps into microcracks, freezes during cold nights. Baalbek's elevation means winter temperatures drop below freezing, expands, and gradually widens the cracks. Over centuries, this process could fracture the stones. Dr. Mass's 2010 survey noted several expanding cracks in the stone of the pregnant woman. Without conservation intervention, filling the cracks with appropriate sealant, improving drainage around the stones, they may break apart within a few centuries. There's been discussion of attempting to move the stone of the pregnant woman using modern equipment as a demonstration of how it might have been done. In 1996, a Lebanese engineer proposed using hydraulic jacks and a custom-built wheeled platform. The project was never approved, largely because authorities feared damaging the stone. Additionally, even with modern equipment, the engineering challenges are formidable. There's no crane in Lebanon capable of lifting 1,000 tons. The largest mobile cranes max out around 750 to 800 tons, and they require solid ground that can support not just the stone's weight but the crane's weight and the dynamic forces during lifting. So the stone sits, cut but unmoved, a permanent monument to their ancient ambition or ancient capability. We still don't know which. The stone of the pregnant woman forces me to confront the difference between ambition and capability. Every culture has ambitious dreams. They imagine monuments, cities, achievements beyond their current reach. Usually, ambition outpaces capability. We dream bigger than we can build. Ancient peoples were no different. But the quarrying of a 1,000-ton stone suggests capability matched ambition, at least partially. They cut it free, after all. The quarrying part was achievable. What happened between quarrying and moving? That's where the mystery lives. Did capability fail to match ambition at that point? Or did something else intervene? The stone sits as evidence of interrupted intention, frozen in the moment between conception and completion. Perhaps what disturbs me most is the silence. Someone made the decision to quarry this stone. That person had reasons, had a plan, had confidence. And we don't know who they were, what they thought, or what happened to them. History is usually written by the successful. The monuments we study are completed projects that proclaim the glory of their builders. Baalbek's quarry shows us failure, or at least incompletion, and somehow that makes it more human, more accessible. These weren't infallible ancient geniuses working with lost super technology. They were people who started something monumentally difficult and didn't finish it. Just like most human endeavors, actually. In 1898, when the German Archaeological Institute began systematic excavation at Baalbek, one of their first tasks was removing the accumulated debris from centuries of occupation. As they cleared away Byzantine additions, Islamic-era modifications, and medieval stonework, they revealed the Roman temple podium. Standard archaeological practice: photograph, measure, document. But when the team's architect, Otto Puckstein, began precise measurements of the foundation stones, he noticed something that would perplex engineers for the next century. The joints between the massive stones were essentially perfect. Puckstein measured joint widths at multiple points along each interface. His measurements, recorded in painstaking detail in the German expedition reports, showed gaps ranging from 0.3 mm to 1.2 mm. For context, a human hair is approximately 0.07 mm in diameter. These gaps were roughly 4 to 17 hair widths across joints between stones weighing hundreds of tons. Modern stone construction typically achieves joint tolerances of about 3 to 5 mm for major structural elements. That's considered excellent work. Ancient Egyptian pyramid construction, some of the finest stone masonry in antiquity, achieved joints of approximately 0.5 mm on the pyramid casing stones, a remarkable feat requiring final grinding of the surfaces after placement. But the pyramid blocks weighed 2.5 tons on average. The ratio of mass to precision at Baalbek is unprecedented. Dr. Friedrich Riget, studying the site in the 1980s, brought modern surveying equipment and measured not just joint widths but also surface planarity. He found that the top surfaces of the foundation stones varied from a perfectly flat plane by less than 2 mm across spans of 10+ meters. This is approaching machine tolerance precision. Riget, an architect familiar with modern construction standards, noted in his 1980 book Baalbek that achieving such precision with hand tools would be exceptionally difficult even for a modern craftsman working on small decorative pieces. What makes this precision even more remarkable is that it exists on the Baalbek-based stones, the massive blocks that underlie even the Trilithon. These are the oldest stones in the complex, potentially Bronze Age. We're not talking about Roman-era precision, which at least we understand. We're talking about precision from an era when the most sophisticated tools were bronze chisels and wooden measuring devices. To understand why this precision is so difficult to achieve, we need to understand stone finishing. When you quarry a stone, you get rough surfaces with irregularities. To create smooth, flat surfaces, you must gradually remove high spots through grinding or polishing. For small stones, this is tedious but manageable. You use increasingly fine abrasives, checking flatness frequently with a straight edge, removing material until the surface is uniform. For an 800-ton stone, everything about this process becomes nightmarishly difficult. First, you can't flip the stone over to work on different faces, it's too heavy. So all finishing must be done with the stone in its final orientation. Second, the sheer surface area means even minor irregularities across the stone translate to substantial volume of material to remove. An average high spot of 2 mm across a 19 m by 4 m face means removing approximately 0.15 cubic meters of stone, about 400 kilograms of material. And you must remove it uniformly, maintaining the plane while grinding. The Romans had sophisticated stoneworking tools. They used iron saws with abrasive sand to cut stone. They used various types of chisels and rasps for surface finishing. They understood the principle of establishing reference points and working to match them. But there's a scale problem. A Roman mason could spend weeks getting a 1-ton block perfectly flat. That's expensive but feasible. Spending months to finish an 800-ton block represents such a massive investment of skilled labor that it strains economic rationality. Why bother? The precision contributes nothing to structural performance. Stones with gaps of 5 to 10 mm would support the temple just as effectively. Dr. Jean-Pierre Adam, in his comprehensive study of Roman construction, calculated the labor requirements for achieving the observed precision. His estimate, approximately 400 to 600 man-hours per square meter of stone surface, assuming skilled masons working with appropriate tools. For 1 Trilithon stone with approximately 140 square meters of exposed surface, that's 56,000 to 84,000 man-hours. Assuming an 8-hour workday, that's 7,000 to 10,500 days of work. If you had 50 masons working simultaneously, all they could physically fit around 1 stone, that's 140 to 210 days, roughly 5 to 7 months of continuous work per stone. Just for finishing the surfaces. This is on top of the months required to quarry the stone and the engineering needed to transport and lift it. The economic calculation doesn't work. Why invest 20+ months of skilled labor per stone to achieve precision that serves no functional purpose? This isn't even visible precision. Once the temple was complete, these foundation stones were largely hidden from view. You're investing enormous resources into craftsmanship that nobody will see, and that doesn't improve the structure. Unless the precision wasn't about aesthetics or even engineering. Unless it serves some other purpose we don't understand. The joints between stones show another peculiarity. In many cases, the surfaces aren't just flat, they're slightly concave, curving inward by a fraction of a millimeter. This creates what engineers call a pressure fit. When weight is applied from above, the stones press together at their edges first, creating a joint that's actually stronger than a simple flat interface. It also creates a joint that's partially self-aligning. If the stone shifts slightly, the curved surfaces guide it back to the optimal position. This is extremely sophisticated. Modern engineers understand this principle and sometimes use it in precision machinery. But creating curved surfaces accurate to sub-millimeter tolerances on 800-ton stones should be impossible with ancient tools. Yet there it is, measurable and real. In 2005, Dr. Daniel Lohman conducted a detailed photogrammetric survey of the Baalbek stones. Photogrammetry uses overlapping photographs to create precise 3D models. Lohmann's team took thousands of photographs from every angle, then used software to generate models accurate to sub-millimeter resolution. The results, published in 2010, revealed patterns invisible to casual inspection. The stones show evidence of different finishing techniques. Some surfaces have faint parallel striations, suggesting grinding in one direction. Other surfaces show a crosshatched pattern, suggesting grinding in multiple directions for final finishing. Most intriguingly, some surfaces show no tool marks at all. They're smooth at microscopic scales, as if polished rather than ground. Polishing stone requires very fine abrasives and enormous amounts of time. The Egyptians polished granite for royal sarcophagi, but granite is hard stone that takes a polish well. Limestone is softer and doesn't naturally polish to the same degree. Achieving mirror-smooth limestone surfaces requires specific techniques, typically involving progressively finer abrasives and final buffing with leather or cloth impregnated with polishing compounds. Why would anyone polish surfaces that would be hidden from view? Lohmann suggested it might have been religious. Perhaps there was belief that every surface, visible or not, needed to meet perfection standards. But this explanation feels weak. Religious devotion can drive impressive accomplishments, but there are limits. At some point, pragmatism intervenes. The effort required to polish hidden surfaces of 800-ton stones crosses into irrationality. Dr. Erwin Ruprechtberger proposed an alternative explanation in his 1999 study. He suggested that the precision wasn't intentional, it was a byproduct of the cutting method. If the ancient builders used some technique that naturally produced very flat, smooth surfaces, then the precision is explained without requiring intentional finishing. But what technique could do this? Ruprechtberger couldn't identify one. Sawing with abrasive produces flat surfaces but leaves clear saw marks, which are absent. Impact tools like chisels create irregular surfaces that require extensive finishing. Thermal techniques using fire and water produce rough, fractured surfaces. There's one technique that could theoretically work: wire sawing. You loop a wire around the stone, pack the joint with abrasive sand, and pull the wire back and forth. The abrasive cuts through the stone gradually, and because the wire follows a consistent path, it creates very flat surfaces. Ancient Egyptians may have used this technique on smaller stones. But for the massive Baalbek stones, you need bronze wire strong enough to withstand enormous tension across spans of meters, and you need to make thousands of passes to cut through. The logistics seem overwhelming, and again, we have no evidence, no fragments of wire, nowhere marks consistent with wire sawing, no historical descriptions of the technique being used at this scale. This next part changed my entire perspective on ancient construction. The conservative theory, championed by Dr. Lohmann and others, holds that the precision is real but achievable through Roman techniques. Romans were patient and methodical. They had skilled craftsmen who spent entire careers learning stone finishing. Given enough time, motivation, and economic resources, Roman masons could achieve sub-millimeter precision even on massive stones. The lack of tool marks might indicate they used the finest possible abrasives for final finishing, leaving marks too small to see without microscopic examination. The precision served both religious and propaganda purposes. It demonstrated Rome's mastery over nature and materials. I've shown this to colleagues and gotten completely different reactions every time. What's your gut instinct telling you about this? The challenge to this theory is the absence of parallel achievements. Romans built extensively across their empire for centuries. They left detailed construction records. Yet nowhere else do we find precision comparable to Baalbek on stones of comparable size. The Pantheon's construction is well documented. It's sophisticated and impressive, but it doesn't approach Baalbek's precision. If Romans could do this at Baalbek, why not elsewhere? The radical theory proposes that the precision indicates a different culture or time period, specifically, that the most precisely finished stones are the oldest, not Roman additions. This inverts conventional chronology. Usually we assume older means cruder. But what if Bronze Age builders, for reasons we don't understand, were more obsessed with precision than later cultures? What if the Baalbek base represents the pinnacle of an ancient tradition, and Roman construction, while impressive, was actually a step down in precision standards? This theory finds some support in the correlation between stone's size and finishing quality. The largest, oldest stones show the finest finishing. Smaller, demonstrably Roman stones show good but not exceptional finishing. It's as if construction quality decreased over time rather than increased, suggesting the earlier builders set a standard the later builders couldn't match. But this theory requires a Bronze Age culture with capabilities that exceed what we see anywhere else in the Bronze Age world. We'd be claiming that 3rd millennium BC Levantine people achieved precision that wouldn't be matched until the Renaissance. That's a radical claim requiring extraordinary evidence, which we don't have. The fringe theory suggests the precision is evidence of machining. The surfaces are too flat, too smooth, too perfect to be handworked. Therefore, some form of mechanical cutting or grinding must have been used. Advocates point to similar precision in ancient Egypt, the granite boxes in the Serapeum, and suggest a widespread ancient technology we've failed to recognize. The absence of tool marks is explained by the tools being so effective they left no marks, like modern diamond-tipped cutting tools. The problem is defining what this technology would be. Ancient machines tells us nothing. What powered them? What were they made of? Why did this technology leave no trace, no fragments, no wear marks on cutting tools, no descriptions? The theory essentially says, something we can't identify or characterize did this, which is admission of ignorance presented as explanation. Imagine being the craftsperson tasked with finishing these surfaces. You've been working on this single stone for months. Every day you arrive, check your straightedge against the surface, identify high spots, and grind them down. The work is meditative and exhausting simultaneously. Your arms ache from the constant motion. The limestone dust coats your skin, gets in your lungs, turns your hair gray-white even though you're young. You know that nobody will see this work once the temple is complete. These stones will be buried under other stones, hidden from view. Yet you continue, maintaining standards that approach the limits of what's humanly achievable with your tools. Why? Because your master taught you that every surface matters. Because your reputation as a craftsperson depends on doing the best work you're capable of, visible or not. Because there's satisfaction in knowing that you created something perfect, even if perfection is buried and forgotten. Or perhaps you work with this level of care because there are inspectors. Perhaps the punishment for poor work is severe. Loss of position, loss of honor, perhaps physical punishment. Perhaps you maintain precision not from pride but from fear. Ancient construction projects were often forced labor or corvée service. If you're a conscripted worker rather than a skilled craftsperson, you maintain standards because failure has consequences you can't afford. Or maybe, and this is the possibility that haunts me, you maintain precision because you know something about these stones that we don't. Perhaps the precision serves a technical function we can't perceive. Perhaps these stones are components in a system, and like components in a machine, they require precise tolerances to function properly. What system? We don't know. But your culture knows, and you work with the care of someone building something that must work, not just something that must look impressive. The precision of Baalbek stones continues to influence modern stonework. Lebanese craftspeople who work in stone occasionally visit the site to study the ancient techniques. Several master masons I've corresponded with describe Baalbek as humbling. It sets a standard they aspire to but acknowledge they probably can't match using traditional tools. In 2015, an Italian stone conservation company proposed creating exact replicas of some Baalbek stones using modern tools, as a demonstration of what's possible with current technology. The project hasn't been funded, but the proposal itself is interesting. The company estimated it would take their best craftspeople, using pneumatic grinders and precision measuring equipment, approximately 6 months to create one replica stone with comparable precision. That's with modern tools and modern measuring instruments. The ancient builders supposedly did it with bronze and string. The precision also creates conservation challenges. When you have stones fitted so closely together, water infiltration patterns change. Water can't flow through the joints, so it flows over surfaces, potentially causing more erosion. UNESCO conservation guidelines recommend maintaining the precision where it exists, but not attempting to recreate it in damaged areas. The skill and time required make it impractical. Standing beside these perfectly fitted stones, running your hand along joints you can barely feel, you're confronted with the uncomfortable possibility that ancient people, in specific times and places, achieved things we can't readily explain or replicate. This doesn't mean they were more intelligent than us. Intelligence is probably constant across human populations and time periods. But it might mean they were more patient, more obsessive, more willing to invest enormous resources into achievements whose purpose we no longer understand. Or it means we're missing something fundamental about their methods. There's a technique, a tool, an approach that's obvious once you know it but invisible until then. Maybe someone in antiquity figured out a shortcut, a way to achieve precision that doesn't require months of hand finishing. If so, that knowledge was never written down or was written down and lost. We're left reverse engineering their achievements without knowing what problems they were actually solving. The precision at Baalbek teaches that ancient people had different priorities than we assume. We build for efficiency, for cost effectiveness, for speed. Perhaps they built for permanence, for perfection, for purposes beyond the merely structural. Or perhaps, and this is the thought that keeps returning, they built knowing something about stone, about place, about the relationship between mass and precision that we've completely forgotten. After everything we've explored, which of these mysteries disturbs you the most? And more importantly, why do you think these stories were hidden for so long? For me, the multi-phase construction reveals something profound about human relationship to the past. Each culture that built at Baalbek was, in its own way, acknowledging what came before. They didn't erase previous work, they built upon it, sometimes literally. This suggests a continuity of reverence, an understanding that the site held meaning beyond any single culture's use of it. We've lost that continuity. We visit Baalbek as tourists, we study it as archaeologists, but we don't build on it. We preserve it, which is its own form of reverence, but also a form of distance. We're saying, that was them, this is us, we're different. Ancient people didn't think that way. They saw themselves as continuing something that began before them and would continue after them. The inverted quality progression, the idea that the oldest work might be the best work, challenges our assumption of inevitable progress. We tell ourselves that technology always advances, that we're always getting better. Baalbek suggests otherwise. Perhaps humans reached certain heights of achievement in specific domains, then those achievements were forgotten or became impossible to replicate due to changed circumstances. Not everything moves forward. Sometimes we lose capabilities, sometimes permanently. The underground mysteries remind us how little we actually know. We've surveyed Baalbek, excavated portions, analyzed the stones, yet there are potentially chambers beneath it that remain unexplored. Multiply that across thousands of ancient sites worldwide, most less studied than Baalbek, and the scope of our ignorance becomes clear. We know some things about the past. We don't know most things. And some things we may never know, because the evidence has been destroyed or buried too deeply or simply isn't recognizable to our current methods. Baalbek's mysteries resist resolution. The Trilithon stones sit where they were placed, impossible in their mass yet undeniably real. The stone of the pregnant woman rests in its quarry, cut but unmoved, testament to uninterrupted ambition. The precision of ancient joints mocks modern capabilities. And the multi-phase construction documents successive cultures building atop mysteries they inherited but never fully understood, just as we inherit and fail to fully understand today. What makes Baalbek particularly significant isn't any single mystery but their combination. One impossible achievement might be dismissed as misunderstanding on our part. But multiple impossibilities, each reinforcing the others, suggest something genuine. There was a capability, a knowledge, a technique that existed and then vanished. I've presented the evidence as fairly as I can, the academic theories, the measurements, the historical context. But standing at Baalbek, touching those stones, feeling their impossible smoothness and trying to imagine the work that created them, academic theories feel inadequate. Something happened there that we don't understand. And that gap in understanding is valuable. It's a reminder that history isn't settled, that the past holds secrets, that ancient people were capable of achievements that still defy our comprehension. The Bekaa Valley continues its life around these stones. Farmers tend fields, children walk to school, cities hum with ordinary activity. And in the midst of it all, massive blocks of limestone sit silent, keeping secrets carved into them millennia ago. They'll sit there long after we're gone, long after our cities have crumbled, waiting for someone, perhaps centuries from now, who finally understands what we could not. The mystery endures. And perhaps that's exactly as it should be.